Hello guys, today we are going to discuss the normal distribution. In particular, we're going to discuss how to use the standard normal table to evaluate probabilities for the normal distribution. So let's go ahead and start. So our heading is the normal distribution. The normal distribution. This is our heading here. The normal distribution. Okay. So we are going to look at examples. We're going to look at two examples. So we're going to start with the first example. And I'm going to write down the problem description. So it's example one. I'm going to write down the description of the problem. And then we're going to go ahead and discuss the solution of this problem. Okay. And then when we finish with that, we're going to go on to problem number two. And we're going to discuss that problem and its solution. Okay. So let's go ahead and discuss the problem. So let's go ahead to example one or problem one. Okay, let me write it down here. So let me write down here. I'm going to write problem one here. I'm going to write problem one. So it's the first problem we do. Okay, so let me write down the problem description. Okay. All right. I'm going to write down the problem description. And then we're going to go ahead and we're going to go solve this problem. Okay. So now for this one, let's assume that X is normally distributed. So X is a random variable. Okay. Right. X is a random variable. And we assume that X is normally distributed or follows a normal distribution. Okay. So assume that X is normally distributed, meaning that X follows a normal distribution, okay, with a mean of 15. So mu is equal to 15 and a standard deviation, sigma, of 3. Okay, so suppose that this is what we have here. So suppose that X is normally distributed with a mean mu of 15 and a standard deviation, sigma, of 3. Okay, so suppose that this is what we have. Okay, so the instruction is use the approximate areas under the standard normal curve to evaluate the following statements. Okay, so that's the instruction. The instruction is use the approximate areas. That's the instruction. The instruction is use the approximate areas. Use the approximate areas under the standard, use the approximate areas under the standard normal curve. So now I'm writing down the problem description. Okay, use the approximate areas under the standard normal curve, to evaluate the following statements. Okay, to evaluate the following statements. Use the approximate areas under the standard normal curve to evaluate the following statements. So this is the problem description. To evaluate the following statements. Okay, so let me read. I'm going to read the problem description again. Problem one, assume that X, which is our random variable, follows a normal distribution, okay, with a mean of 15, mu is equal to 15, and a standard deviation, sigma, of 3. So sigma is equal to 3. Now we're going to use, they say, use the approximate areas under the standard normal curve to evaluate the following statements. Okay, so now we're going to go to the statements now. Okay, so let's go to the next page. Okay, let's go to the next page. So statement number one, okay, the probability that X is at least 15. What is the probability that X is at least 15? So that's the first statement. So this is the first calculation that we have to do. Okay, it's the first calculation that we have to do. So we know that the mean is 15, right? we know that the standard deviation is equal to 3. Now they're asking us, they say, evaluate the following statements. So with that knowledge, we have to now evaluate the probability that x is at least 15. So how do we do that? How do we evaluate the probability that x is at least 15? Okay, so first of all, we are going to use the standard normal table. Okay, we know that x is normally distributed. It follows a normal distribution. So therefore, because it follows a normal distribution, we can standardize x. X can be standardized, meaning that it can be, we can use a formula to write x as a standard normal random variable. And then we can use that in order to evaluate this probability. Okay, so how do we do that? So the formula that we use is as follows. Okay, the formula that we use is as follows. Okay, we say z is equal to x minus mu divided by sigma. So this is how we standardize a random variable that follows a normal distribution. Okay, and in this case, x does follow a normal distribution. So to standardize x, we say z is equal to x minus mu divided by sigma. That's how we standardize x. Okay, so therefore, how do we apply this formula to evaluate this probability? We say, therefore, okay, the probability that x is at least 15 is equal to the following. It's equal to the following. It's equal to the probability that x minus mu. So now we apply this formula. We go x minus mu divided by sigma. So now we apply this formula for standardizing the random variable. So we go x minus mu divided by sigma. And what we do on the left side of the inequality, we also do on the right side of the inequality. So we're also going to go 15 minus mu divided by sigma. And we close the bracket. So this probability that we're looking for, the probability of x is at least 15, is equal to the probability that x minus mu over sigma is at least 15 minus mu over sigma. Okay, so and we know what mu and sigma are for this problem. So we've got, this is equal to the probability that x minus mu, and in this case mu is 15. Okay, we already know that mu in this case is 15. So this is x minus 15 divided by sigma, and we know what sigma is as well for this problem. And sigma in this problem is 3. So we just put 3 there. And this is at least 15 minus 15 divided by 3. All right. So now this over here, we can just write it as z. We can just put z here because of this formula here. When you go x minus mu over sigma, you can just replace this with z. Okay, because now you've standardized it. It now follows a standard normal distribution. So now you can now replace that with a z. So this is basically equal to the following. So this is equal to z. So you replace that with a z at least. And 15 minus 15 is 0. So this is just going to be 0. Okay. So basically the probability that x is at least 15 is equal to the probability that z is at least 0. It's the same. So now all we have to do is calculate, using the standard normal table, the probability that z is at least 0. So now how do we do that? How do we use the standard normal table to evaluate this probability? How do we do that? Now, it really depends also on what kind of standard normal table are we using. Is it a standard normal table that calculates or that gives values for the right tail or for the left tail? So it depends which type of standard normal table you are using. Okay, so the one we're going to use in this case, we're going to use the one for the right tail. Okay, the one that deals with the right tail. And I'm going to share that with you on the screen here so you can see what it looks like. So let me just quickly go share this standard normal table quickly so we can see what it looks like. We can see the one that we're going to use here. Okay, so let's quickly go and look at this. Okay, let me just go back there. So let me share with you the standard normal table that we're going to use in this case. So this is it here. It looks like this. So as you can see here, this one is for the right tail. It's for the right tail. So how do we use this table? How do we use this standard normal table in order to evaluate this probability? How do we use it? Well, we are calculating the probability that z is at least 0. So that basically means this. If you look at this graph here, this curve on top of the table, you can see it's a bell-shaped curve. It's a standard normal curve, and you can see that there's a shaded part of this curve. If you look between 0 and z, that part is shaded. Okay, so the area under the curve between 0 and z is shaded. So meaning that this table, it gives us the areas between 0 and small z. It gives us those areas. So all the values that you see within this table, okay, except the values that are on the far left, which is these values here, sorry, except for the values on the far left, which is these values here, in the first column here, that are written in bold, those values are for the small z. So the values that are written in bold on the left and in bold at the top here, these are for the z values, okay? That's for the small z values. But the values within the table, the values that are within the table, these are the values that give you the area under the curve. So these values give you the areas under the curve between 0 and z. So therefore, now how do you use this table? Okay, how do you use this table? So in our case, we are calculating the probability that z is at least 0. So in this case, 0 is small z in this case. Okay, 0 is small z. 0 is small z. So meaning that the area that we are calculating is the area that is between small z and positive infinity. That's the area that we are finding. The probability that z is at least 0 is given by the area under this curve between small z here and positive infinity. That's the area that we are calculating. And to get this area, we have to use the fact that, first of all, the area under this curve here, this standard normal curve, is equal to 1. The total area under the whole curve is 1. And the total, and half of that obviously is 0.5. And this curve is symmetric about the vertical axis. So therefore, the area between 0 and positive infinity under this curve is equal to 0.5. So therefore, to find the area between small z and positive infinity, you have to say 0.5 minus 0.5 minus the area that we get from the table, which is the area between 0 and z. That's what's going to give you the area between z and positive infinity. You go 0.5 minus the area given by the table. So that's how you use this table here, because it's a right tail table. So that's how you use it. So in our case, the small z is equal to 0. In our case, the small z is 0. Okay, so if the small z is 0, now using the values on this table, on the far left and at the top, you go and locate 0. You go find 0, which is small z. So you go, okay, go to the first column, and at the top there, you see there's a 0.0 here. This value here, that's 0.0. Okay, so 0.0 plus the 0.0 at the top there in the first column, it gives you 0. So that is the small z. For this case, it's 0. And then if you look at the corresponding value that corresponds to that, that value is 0.0000. It's 0.0000, which is basically just 0. All right. So therefore, the area under this curve between small z and positive infinity is therefore equal to 0.5 minus 0. Okay, it's equal to 0.5 minus 0. So Now, going back to the, let's go back to the whiteboard. Going back to the whiteboard, we've seen there on the table, okay? We've seen on the table that the area that we're looking for, this which gives us the probability that z is at least 0. This area is equal to 0.5 minus 0. And this 0 here is the value of the area that we found from the table. Okay, it's the value of the area between 0 and z that we found on the standard normal table. So therefore, the probability that z is at least 0 is equal to 0.5 minus 0, which of course obviously gives us 0.5. It obviously gives us 0.5. So that's how you evaluate this one. Okay, if you look at that table, this is it's very simple. It's very simple. I'm sure you also saw this even without having to subtract the 0 from the 0.5, because the area between 0 and positive infinity is obviously 0.5. Okay, but the procedure that you can follow when using a standard normal table with the right tail, or for the right tail, is that you have to say 0.5 minus the value that the table gives you. All right, so your answer in this case is just 0.5. Okay, which is basically equivalent to 50% probability. 50% probability. So that's the probability that you get. All right, so that's the first example here, or the first problem that we look at. Okay, and then the second one that I want us to look at is number 2. What if now you are given the following to calculate? Okay, what if now you have to calculate the probability that x is at least 12 and at most 18? What if you are given the probability, or that you are given this problem where you have to calculate the probability that the random variable x is between 12 and 18, that is at least 12 and at most 18. So if you draw a rough sketch of that, so just to see a picture of what it looks like, okay? Just draw a picture and to see what this looks like. So just a rough sketch of the standard normal curve, okay? Not accurate, just a rough sketch. Now, what exactly are you looking for? Okay, what are you looking for? So this is now between 12 and 18. So this is the standard normal here. But before we do that, before we look at what area we're looking for, let's quickly just standardize this, because we have to standardize it. Okay, in order to use the standard normal distribution, we have to standardize this. So therefore, we have to go like this. We have to go 12 minus 15 divided by 3. Now this is at least, so x is at least that. No, sorry, x, we have to do the same thing to x, okay? Because when you're standardizing, you have to do the same thing throughout the inequality. So now we're going to have x minus 15 divided by 3, okay? And this is at most 18 minus 15 divided by 3. Because our mean is 15 and our standard deviation is 3. So this is equal to the following. So this is equal to P of the following. So now we've got 12 minus 15 over 3. And if you work that out, you're going to get minus 1. This is and of course, x minus 15 over 3, we standardize that random variable. So therefore, we can just put z here. All right. And we have 18 minus 15 over 3. That's just 1. So you got z is between minus 1 and 1. So what's the probability? What is the probability that z is between minus 1 and 1? So now this is standardized. We can now go ahead and use the standard normal. Okay, so let's go to this rough sketch we have here. And this is indicate on the sketch what are we looking for. So suppose this is minus 1 here. And of course, that's a positive 1 that side. So the area that we're looking for is the area under the standard normal curve between minus 1 and 1. So the area that we're looking for is basically this area here in the middle, we are looking for the area here. This is the area we're looking for. We're looking for the area in the middle. Okay, I'm just quickly shading the area that we're looking for. Shading the area that we're looking for. So the area that we're looking for is the area that I'm shading in purple. The area we're looking for is the area that I'm shading in purple. It's the area between -1 and 1. That's the area that we're looking for. So how do you find this area? How do you find it? How do you find this area using a standard normal table for the right tail? How do you find it? Okay, we're gonna find this. We're gonna find this area. We're gonna find it by doing the following. We are going to calculate this area here. Okay, we're gonna calculate this area here. This one here, the tails. All right. That's what we're going to do. So we're going to calculate these two areas that are shaded in green. We're going to calculate these two areas that I've shaded in green. And then we are going to subtract these two areas from 1, because 1 is the total area under this curve. So we're going to say 1 minus the sum of these two areas, and that is going to give us the area in purple, which is what we're looking for. And this area in purple is the probability that Z is between -1 and 1. So the probability that Z is between -1 and 1 is given by this area shaded in purple. And to find it, we have to find the areas on the right tail and on the left tail that are highlighted in green. And then subtract them from 1. And then that'll give us the area in the middle, which is the area that's shaded in purple. So therefore, let's go ahead and do this. How do you find these areas, the ones that are shaded in green? How do you find them? Using the table, using the standard table or the standard normal table for the right tail. So to find that, you do the following. To find that, you do the following. You find the probability, okay? You find the probability that Z is at least 1, okay? When you find the probability that Z is at least 1, that will give you the area between 1 and positive infinity that we shaded in green here on the right tail. So the probability that Z is at least 1 is equal to this area that's shaded in green on the right. And we can find this probability that Z is at least 1 by using the standard normal table for the right tail. Okay, and this is basically going to equal to the following. This is going to equal to, it's going to equal to 0.5 minus the area between 0, which is between the origin here, and 1, which is given by the standard normal table. Okay, so now let's go to the standard normal table and find this area between 0 and 1. Okay, let's find the area between 0 and 1. Let's go find it. So let's go to the table and see what this area is. Okay, so we go to the table. Let me share the table again with you. So let's go to the table and see. So we go to the values on the far left of the table and we find 1. And this is 1 here. So that's 1. Okay, if you look here, you see that this is 1 here. It's written as 1.0. It's this one here, written as 1.0. And of course, 1.0, the number that corresponds to 1 is the number over here. It's 0.3413. That corresponds to 1. Remember the 1.0, that's the Z value. Okay, so if you go 1.0 plus 0.00, you get 1.0. You get 1. So the number that corresponds to 1.0 or 1 is this number here, 0.3413. That's the number that corresponds to that. So therefore, this is the area. This 0.3413 is the area between 0 and 1. That's the area we're looking for, the area between 0 and 1, because that's the area that we need to subtract from 0.5 in order to find the area between 1 and positive infinity. So now we found the area. It's 0.3413. So now let's go back to the whiteboard and let's complete the calculation. Okay, so we go back to the whiteboard now to complete our calculation. And so now the probability that Z is at least 1 is clearly now equal 0.5 minus 0.3413. Okay, very clear, right? So now this is equal to the following. This is equal to 0.1587. It's equal to 0.1587. That's what it is. The probability that Z is at least 1 is equal to 0.1587. That's what it is. So therefore, this means that this area here that we shaded in green here on the right side is equal to 0.1587. And it's the same. And this is the same as, this is the same as the area on the left between negative infinity and -1. So this over here is the same. It's equal to the probability of a Z is at most -1. It's equal to that. It's equal to that. Okay? It's equal to the probability of Z is at most -1 because of the symmetry of the standard normal curve, because of the symmetry. So therefore, this means that now the probability between, or the probability of Z, or the probability that Z is at least -1 and at most 1 is equal to 1 minus 2 times this 0.1587. Okay? The probability that Z is at least -1 and at most 1 is equal to 1 minus 2 times this 0.1587. And we say 2 times because we add them. We add this area on the left shaded in green and the area on the right shaded in green. We add the 2. And when we add the 2, we get 2 times this one here because of symmetry. Okay, we get 2 times 0.1587 because of symmetry, because the standard normal curve is symmetric about the vertical axis. So therefore, to find this probability that Z is between -1 and 1, we simply say 1 minus 2 times 0.1587, and that gives us 0.6826. It gives us 0.6826. Okay, so that's the answer for this one. As simple as that. So now we're going to move on to the next one, which is the last one. We're going to move on to the next one, which is the last one. So let's move on to the next one, which is the last one, which is number 3. Let's move on to number 3. Now with number 3, we are asked to find the probability that X is less or equal to 9. What is the probability that X is less or equal to 9? Or the probability that X is at most 9? What's the probability that X is at most 9? Again, we're going to standardize this because we want to use the standard normal table. So we're going to standardize this. So how do we standardize this? As we have been doing. We just go X minus 15, which is the mean, and we divide this by sigma, and the sigma is 3. Okay? And this will be at most 9, because what we do on the left of the inequality, we also do on the right. So basically, we do the same thing throughout the inequality so that the inequality remains the same, basically. So we got X minus 15 over 3 is at most 9 minus 15 over 3. That's what we have. Okay? So therefore, now this is equal to the following. It's equal to the probability of Z, because now the X minus 15 over 3 is Z, because we've standardized it. And this is at most 9 minus 15 over 3. 9 minus 15 over 3 is 2. If you calculate that, if you simplify that, you get 2. So the probability that X is at most 9 is basically equal to the probability that Z is at most 2. So now how do you find this one? How do you calculate the probability that Z is at most 2 using the standard normal table? So let's just draw a little sketch again, a little rough sketch. So you can see, guys, that sketches help. If you're dealing with this, if you're doing these calculations, always draw sketches so you can have a visual picture of what you're doing, which helps you with your calculation, which makes the calculation simpler. Okay, so let's just quickly draw just a rough sketch of the standard normal distribution. Just a rough sketch. It's not accurate, it's just rough, just to help us with our calculation. Okay, so now which area are we looking for? Okay, let's okay, let's do the following. Let's do the following. Let's see. Okay, I think there's something I'm missing here. I've got 9 minus 15 over 3. I'm missing a minus sign. Let's just put a minus sign here. Okay, there we go. So put a minus sign there. It's minus 2. Instead of 2, it's minus 2. 9 minus 15 over 3 is minus 2. Okay, so we fixed that little mistake there. It's minus 2. So the probability that x is at most 9 is equal to the probability that z is at most minus 2. So we would draw a little sketch, okay, just a rough sketch of the standard normal curve. And let's just go and see now. And let's just go and indicate minus 2 there on the sketch. Okay, so suppose this is minus 2 here. Let's just go there. Again, this is just rough. It's not to scale, it's just rough. So let's indicate minus 2 there. Now, so if this is minus 2 here, and this is our standard normal curve, then the area under the curve between minus infinity and minus 2 is the area that we look, that's the area we're looking for. So the area we're looking for basically is the area under the curve. Now the standard normal, it goes close to this. Okay, this is, again, guys, this is rough. Sorry for the sketch, it's rough. So it's supposed to just get closer and closer over there, get closer and closer to the horizontal axis. So the area that we're looking for is this area here. We are looking for, let me shade it in purple, okay? We are looking for this area here. The area shaded in purple. This is the area between minus infinity and minus 2 under the standard normal curve. That's the area we're looking for, okay? This area here. Between minus infinity and minus 2 under the standard normal curve. That's the area that we want, okay? That's the area that gives us the probability that z is at most minus 2, or that z is less or equal to minus 2. That's the probability that we want. So, but the standard normal table that we are using is for the right tail, and this is the left tail here. So now what we're going to do is we're going to use symmetry. So we use symmetry to find this one. And by that, I mean the following. I mean that because of the symmetry of this standard normal curve, we know that the area between 2 and positive infinity on the right side, this area is equal to the one that we want. Okay, so this area here, I'm also going to shade it in purple. This area here is exactly the same as the area between minus infinity and minus 2. The area between 2 and positive infinity is exactly the same as the area between minus infinity and minus 2. So we're going to find the one that's between 2 and positive infinity, because the table we're using is for the right tail. Okay, so let's go ahead and make that statement. Okay, so you can see that the picture, the rough picture, the sketch, it helps us see that. It makes the calculation simpler. So what we've just seen that the probability of z being at most minus 2 is the same as the probability that z is at least minus 2, at least 2. So the probability that z is less or equal to minus 2 is equal to the probability that z is bigger or equal to 2, as we can see from the sketch. And this is because of symmetry. It's because the standard normal curve is symmetric about the vertical axis. That's why this is so. So therefore, now this just became easier, because now we know that we're going to go use the table, and we're going to go 0.5 minus whatever value we get from the table. So now let's go look at the table. Let's go look at the table for small z is equal to 2. So we go to the table and we go find the corresponding area for small z is equal to 2. Okay, so let's quickly go to the table again. I'm going to share that with you again. Okay, let's go to the table. So now let's go find 2, because we're looking for the corresponding area for small z is equal to 2. And there's 2 over there. It's 2.0. And of course, the first column here is for, it also corresponds to 0 over here, okay? So we'll go to 2.0 plus 0. We get 2.0, which is 2. So which means that the corresponding area that we're looking for is this one here. Okay, it's 0.4772. That's the area that we're looking for there. So now we're going to go 0.5 minus 0.4772. Okay, so let's go back to the whiteboard and do that. Okay, let's go back to the whiteboard and complete this calculation. Okay, so now again, the probability that Z is the probability that Z is at least 2 is equal to 0.5 minus this area we just found on the table, which is 0.4772. Okay, so when you calculate that, you go 0.5 minus 0.4772. That gives you the following. It gives you 0.0228. Okay, so that's your answer. So this over here is your final answer.